This is Two Wheelbarrows in a Place We Call Home with Josh Carroll and Brent Rollins.
All right, Mr. Brent, another podcast ready to go. Let's talk about some concrete strength.
Awesome. Yeah. So, strength is the parameter that is used for selling of concrete to a customer. So, when you call up and order concrete, you're going to specify strength.
Yes, but why? Why is that the parameter? Why do ready-mix producers sell it by the strength? What does strength matter?
Yeah. Strength matters because it's going to give you the concrete's capacity to support a load of some kind, and it can indicate it's generally an indicator of durability from a load perspective. So the engineers use it to provide assurance that the building or the pavement is going to carry the loads it should. Fill in any time.
I was letting you go with it. Just make it easy.
Yeah.
They design it to hold certain amount of pressure.
Yep.
And this is what it's for. So that's pounds per square inch.
Yep.
Whether it's 3,000, 3,500, 4,000 PSI, or, MPAs if you're outside the United States.
Yes.
That's the strength that they're looking for, whether it be compressive or flexural.
Yep. Usually, I'd say of all the jobs I've run across, 95% plus are compressive strength specifications where you're meeting a compressive strength requirement, design compressive strength requirement, with flexural being in the pavement world, concrete pavements,
roadways, bridges,
a lot of those,
parking lots, the airports.
Yeah, airports.
I ran more beams at airport than I did anything else. Even bridges, I was making a lot of cylinders. But when it came to airports, flexural strength is what they're looking for.
Yes, it was. And we can get into to the how the different molds, different tests, and the way things are done. But it boils down to strength of the concrete mix is what the concrete company knows is going to provide at a given water content, what it's going to provide for you on your job site within a degree of certainty. And what I mean by that is just simply that concrete's a variable material. As mentioned in previous podcasts, sand, moisture, water, weather, there's all sorts of variables that you're trying to keep control of to produce a good quality concrete. Some of those variables also impact strength, and so you use statistical analysis. Your concrete company is going to use statistical analysis to figure out where they need to be, what the standard deviation needs to be of a particular concrete mix, and what their average compressive strength needs to be to not have a chance or only a very, very small chance of anything falling below that design strength.
Let's make that a little more simple.
Yeah.
If it's a 4,000 PSI design strength, you want it to break X amount higher.
Yes.
So that you don't have a chance of it getting below 4,000.
Right.
From a ready-mix producer standpoint. From a laboratory standpoint, that's what you're testing to.
Yep.
From a design standpoint, there's a factor of safety in there.
Yes.
So it's all working in conjunction. Basically, at the end of the day, Joe Public is not going to worry about a building or bridge or anything falling on them.
Exactly.
And that's really what we start talking about compressive strength.
And
or flexural strength is, the concrete being able to take pressure and rebound back in many ways so you don't have a failure at the wrong time.
Yeah, concrete strength matters because of life safety. That's what it
ultimately comes down to is for everything to do what it's designed to do for Joe Public and safety.
Yep. So just as an example, my standard everyday 4,000 PSI interior concrete mix at the concrete company I worked for, we averaged about right at 4,800 PSI at 28 days. So the requirement was 4,000, but our average break at 28 days was around 4,800. So that gives you an idea of about the over design is what we call it. The over design in any given mix is going to be based on that confidence that you're not going to have.
Yeah, and at the end of the day, you talked
The
about
water
it, the payment on it, but it wasn't just a payment on it. I mean,
Mm-hmm.
at some point in time, if you're not getting it, that's a lot of concrete coming out and being replaced. It's a lot of money.
Yes, it is.
So, you know, I started back in the early 90s testing concrete, 93. And, you know, looking from the 90s, sometime in the late 90s, early 2000s, I seen a shift. It was no longer, if it was a 3,000 mix, you know, getting just above 3,000 at 28 days. You started seeing a shift to all the ready mix producers were getting that design strength from 28 days back at 7.
Yeah.
So if it was designed for 4,000, you're seeing that at 7 days and not, you know, just barely squeaking by.
Yep.
So you were getting at 4,800. You were getting over 5,000 sometimes.
Yep.
So you've seen this shift on it. And to kind of get into testing, that's where we're actually taking a cylinder mold for compressive strength, you know, taking concrete, putting it in the mold, consolidating it,
Yep.
letting it sit there overnight, 24 hours, picking it back up, putting it into a curing environment, whether it's in the moist cure room or, you know, water, and then holding it in there till the day of the break, whether it's 7 days, 3 days, whatever we're talking about.
Yep.
And depending on what you're looking for, it could be 1 day strength, it could be 3 day strengths. So, and we'll get into
That's a
the
great
strengths
point.
later.
Yeah.
But for the most part, it's 28-day design strength. And, you know, at 7 days, typically, if I was seeing something below 70, 75% of design, I was making a phone call to Rayman Experience like, hey, we need to watch this one.
Yep.
But, you know, if we're getting at 75 or over, rarely do I see anything happen at 28 days. You know, so that way we're just getting ahead of it, letting the general contractor know, hey, we need to watch this. Because the last thing, I mean, you have stories of where,
Oh, yeah.
you know, I think one of the ones that me and you looked at was many years ago. You brought me something that said, hey, man, what do you think about this? And I looked at it. I was like, well, it's kind of funny. How did you get 28 days when it was only, you know, 3 days old?
Yeah.
Where another testing company had broke your cylinders way early and was yelling about how you had a low break.
Sent out a low break report to the GC, the owner, and everybody involved that we'd had a low break, and it turned out to be a 3-day break rather than 28. So those kind of things do happen. You mentioned something that I wanted to bring up, which was we have some stories.
We always have stories.
One of my favorite low-strength investigations that I ever did, that I've told this story so many times. I'm gonna edit out the names to protect the innocent, but I was on a particular project that was a school, and it was a second floor deck that we were doing. It was a rather large second floor deck, and it was split up into about 4 or 5 pours, and for some reason the placements, the placements were spread out. I believe, if I remember correctly, this is 25 plus years ago. So I believe it was weather related. They weren't able to pour concrete as often as they wanted. But so I get a low 7-day break back on the first placement. And I go out to the job site. I checked all my normal QC way of doing things is when I got a report of a low break, I would start digging in. I'd dig into the batch records, make sure that the computer actually loaded all the constituents at the amounts that were supposed to be there. I looked at the ticket to see if there was a bunch of water added. I looked at, and then from there, if I didn't get an answer in the batch records or the water added on the ticket, I would go check out the aggregate stockpiles, double check gradations, double check cement mill test report. And my last step in the process typically was to go to the job site just to observe. I'd go to the job site on the next placement and see what was going on. In this particular placement, I didn't make it to placement number 2 for some reason, but I made it to placement number 3, which was on consecutive days. So you had placement number 2 happened. The very next day I was there for placement number 3. It's about 150 yards or something like that. And I'm watching from the front seat of my pickup truck, and I see the testing lab technician get cylinders from the previous day pour placement. And he walks them over to the edge of the second floor and drops them off the second floor onto the ground.
That was not with the testing company I worked for. Let me just go ahead
It
and
was
caveat
not.
that.
It is actually a testing company that's not in business anymore. But imagine that. I walked over to the testing lab technician and I said, buddy, what are you doing? And he said, "Oh, they're set up. They're good." I said, "Not to be throwing them off of a second floor onto the ground. You're not going to treat my cylinders that way." And then there were some choice words said between the two of us. But long story short, the strength in place was fine. We did some coring. We did some other things. And the testing lab paid for it.
Well, we'll get into the way you test that. So.
Yeah. So that's one story. There's many others, but probably we'll tell at least one more before this podcast is over today. But so we mold cylinders in a cylindrical shaped mold. In the old days, it was 6 inches in diameter by 12 inches tall.
Yep. Now we're down to 4x8.
Now we're down to 4x8
because it just for a couple different reasons, but I enjoyed it mostly because they weigh so much less than those.
You can carry 2 4x8s at a time when you really. I mean, some people can carry 2 6x12s at a time, but I wouldn't advise it.
Well, under normal concrete, 6x12s are about 30 pounds each, and 4x8s are 8 to 10.
Yeah. So, what about flexural strength? You mentioned beams earlier. What are you making when you're making flexural strength samples?
Well, you just said beams. I mean,
what do they look like? In case somebody
beams,
hasn't seen them,
like a bread mold. 6x6 by 20 inches.
There you go.
And in both cases, you're rodding or vibrating depending on your slump. That we talked about workability. To mold those, let them sit.
Rodding beams is a little bit more of a workout, though, if I remember.
Everything is, when you're rodding, is more of a workout. And if you got to make a bunch of them, you're in for a long day of your arms moving up and down, rodding those things.
And my record was 12 beams and off of one load of concrete.
Why?
It was an R&D project for a carpet manufacturer who was trying to put their carpet fibers in concrete.
So you did it yourself?
Yes. Yes.
You can't blame anybody for your own misfortunes.
No, I did it myself, but that was an interesting project.
So even the beams, and then there's a most time you're seeing a 3-point loading method on the beams and braking to get the flexural strength on it.
ASTM C78 for those that are interested.
We'll always plug standards and documentations from ASTM or ACI. You mentioned seeing what was going on in place.
Yep.
And you've done, unfortunate, a fair amount of it. Generally, when you had another testing company throwing cylinders off, that I'd had to come out and test for you.
Yep.
And typically there was 3 tops we could do for in place. And one was a Swiss hammer or Schmidt hammer.
Mm-hmm.
Another one's a Windsor probe.
Mm-hmm.
And coring, which was always my favorite because I actually got to see what it was.
Yep.
Mainly a Swiss hammer is giving you rebound. It's an indication of hardness.
Yeah.
And typically what I would do as an indicator is I'd actually hammer a cylinder and break it. And yes, there's a calibration on the hammer, but I always wanted to see how close it was to what I was getting in, from a cylinder.
Sure enough.
Then go out and check it and see kind of where we're at. And I usually would use that in conjunction with coring to find out where my trouble spots might be.
Yeah. Yep.
Especially if we didn't have a whole lot of information going to a job site that we had nothing to do with. Then we had a Windsor probe.
Yeah, that's my favorite quote unquote non-destructive compressive strength determination. I really like Windsor probe, but it requires homework, and the homework for Windsor probe is like you were talking about with the Schmidt hammer. You're shooting concrete. If I remember correctly, 3x3 cube of concrete. Basically, you make it and you make a bunch of cylinders out of the same concrete that's in that cube. You don't want to shoot a cylinder with a Windsor probe.
No.
Let me just tell you that. So for those that don't know, Windsor probe uses a 32 caliber powder charge to fire a stainless steel pin into the concrete, and based on the depth of its penetration, you can draw a correlation to compressive strength. It is really a hardness test, much like the Schmidt hammer, but you do your homework up front where you shoot that 3x3 block, measure your depth, and you break a cylinder immediately, and then you draw a correlation between the depth of penetration of that little metal rod and your compressive strength samples that you actually break in the hydraulic press. For me, that Windsor probe was better than the Schmidt hammer only because it seemed to give more consistent results, but it was still not a substitute for acceptance for coring.
Well, no, but you also need to know if you hit something. So you're putting in 3 probes per location to
Yep.
see, and if all of a sudden you got something that's off, you need to be have the wherewithal to know something's in that concrete right there. I could have hit a piece of rebar, something else I need to turn, because the deeper in the probe would go, the less strength it indicated. The less it did, the higher the strength.
Funniest, I got to share a funny Windsor probe story.
If it's not the one that I'm thinking of, we're going to have to tell that one as well.
Okay, well, so I get a call from a fellow division QC manager at the concrete company I was working at, and he had some low strengths on some columns at an airport. I didn't know it was at an airport yet, right? So I tell him, okay, he tells me I've got some low strengths on columns. And I'm like, okay. He says, can you bring your Windsor probe and let's investigate? And I said, sure. So I show up at the plant, and he's busy, and he tells me, and this guy's passed away, unfortunately. We lost a good one when we lost him. But he said, hey, Brent, I'm in a hurry. Follow me to the job. And I'm following him to the job. And here I've got a Windsor probe in my truck. I've got powder charges in my truck. And he then takes an exit for an airport. And I call him on the cell phone, and I said, hey, Dave, buddy, are we going to an airport? And he says, yeah, we're going to. I said, but Dave, I've got what is essentially a firearm in my truck. Is this going to be okay? And he's like, yeah, don't worry about it. It'll be all right. Famous last words. So went to the parking garage, ran the tests, and believe it or not, nobody ever, it was a brand new parking garage, so it was a construction site, so I didn't have to go through security. Nobody ever said anything or did anything. Obviously it was not a controlled area, so I don't think I actually committed a crime. But the columns turned out to be fine. The cylinders in that particular case had some trouble in handling or something. So when we talk about strengths, so if you can imagine my nervousness, I did a really bad job of telling that story just now. But if you can imagine my nervousness and my sweating in the middle of summertime at the time at North Alabama, in the middle of summertime, oh boy, I still have nightmares about it. So when there's a lot of things that can go wrong with strength testing, and the bad part, I feel for you, Josh, because you worked nearly 30 years in the independent testing industry, and you got to be the recipient of a lot of phone calls, a lot of people saying you guys did something wrong.
I didn't have that many.
Okay, good.
Luckily, I didn't have that many, but
Good.
we did have some where, I had some. Went to pick up some cylinders one day and I couldn't find them, and I looked over and the guy on a dozer was burying them.
Yes.
I've had, finishers I look back on, they're like, oh, it was a great place to sit and have lunch. I'm like, get off my cylinders.
Oh yeah, I've seen a few cylinders with butt impressions.
And so those are ones we were marking and going, hey, there's an issue. So if they did get low strength, everybody kind of knew something was going on, and we just go test it. Now, of all the Windsor probe stories, the one I thought that you were going to tell was when we were out shooting in a neighborhood, some low strength perceived concrete, and as we're shooting it, the police pulled up on one street over, and me and you were both like, don't know that we need to shoot this thing right now.
Was that like curb
job?
It was
curb and sidewalk.
Yeah, I thought so. Okay.
And it was one of those that we waited till they were gone and made sure everything was good, because the last thing you wanted to do, either you or I wanted to do, was to shoot that 32 caliber with police just right over, and they'd already came in for a domestic dispute. Didn't want to do it. So that's what I thought you were going to go with.
They were probably called up on us because somebody heard that powder charge going off. The absolute worst one that is just burned into my brain from 25 or 30 years ago was I had a wastewater treatment plant that had some questionable breaks, and they wanted me to come out. And I go out there, and I didn't think much about it. But again, in the middle of summertime, this was North Georgia area, and it's hot in North Georgia, hot and humid. And I go out to this water treatment plant, and I asked the GC, okay, I'm here, I'm going to do some investigation. This is what I'm going to do. I ran him through it so he'd know what to expect. I said, can you show me where the concrete that this load went into? And he took me over to one of the ponds.
Oh.
And it's the middle of summertime.
Yeah.
I don't know if you've ever been around a water treatment plant in the middle of summertime, but if you want your face about 3 feet from the pond while you're testing concrete on the side, that's not pleasant.
That was the literal part of you. You probably were up the creek without a paddle.
Oh, it was.
For those who do not understand, we're intimating the pond being
It's stinky.
Yeah.
Stinky does not even begin to describe it. I had to throw those clothes away that I was wearing that day because after washing them 3 times, they still smelled. So
Probably just throwing away just for the sake of it. But,
yeah, well,
so
hopefully we'll get to tell some other stories too down the road about
but,
the chicken houses. And
it's not
okay.
We're talking about testing of strength, and we're talking about if there was low strength from early placements, but these also can be used for when you just don't know.
Yep.
I've went and cored some older concrete, and the one I can remember is it was a building that was built in the early 1900s, and so this was probably late 90s, so 98 to early 2000, and we were asked to core drill, and the only way there was wooden steps, wooden floors, uneven. They were like one of you walk at a time. We actually had to manually pull the coring machine up outside the building and set it in because the steps and everything was not going to carry the weight, which is always a concern for us. And I go coring the first one, and I called the structural engineer. I'm like, we just need to stop. He goes, why? I'm like, well, normally when you pour a core, pull a core, when you pull it out, it's a cylinder of concrete, and you pull it out of the core barrel, and you put it in a bucket, and you wrap it up, make sure you don't do anything detrimental to it, and you go back and you break it. And I'm not getting all of it. You're supposed to actually put it in plastic at all. There's a lot more to it when you're doing that. And I'm just giving you the overview. When I went to pull this core out of the barrel, when I turned the barrel up, because I was coring sideways into a wall. Yeah. All I got was rock. Oh. It disintegrated just with the water going through it.
And this is concrete that's holding you up.
No, well, it's the side walls, and it's just. This was more than just the rickety wooden steps. This was a problem, and the structure there was nice and agreed that we probably needed to stop and get out of the building, so we did. Yeah. It's not typically what I ever want to see. I want to see good hard concrete coming out. I mean, when it comes to coring, river rock was always the one I hated the most because it just was hard. The rock itself was hard. It took you a lot longer to get through it with the core barrel than limestone.
Pervious concrete was my least favorite to core.
Because the water was gone as quick as you could. I mean, you're just trying to get through it. But let's go back to fresh concrete. Yep. Going to go back to your days in the ready mix and just to get everybody on the same table is, and you're going to find as we do this podcast, there's a lot of the same phenomena coming up when we say this can affect it. Sure. So when we talk about strength, what are we looking at that can affect strength of the concrete?
Yeah, I mean, it's going to start with water to cementitious ratio. And what I mean by that is the amount of water that you have in the mix is the number one culprit when it comes to low strength. There was a great structural engineer that I thought the world of by the name of, oh man, I'm losing it.
You're getting old.
Yeah. Jeez.
We talking about Mr. Hill or we talking about somebody else?
Yeah, Robert Hill. Robert Hill with Brockett Davis Drake in Dallas. Robert Hill was again, he's another guy that unfortunately has moved on to his reward, but
he's designing better things.
Yeah, exactly. So Robert, I called him up one day on a project we were doing, and I had some strength issues. And I called him up. I was like, I just can't figure it out. I was trying to explain to him that I could, and he said, Brent, I don't know what to tell you other than it's water. And I said, well, how can you be sure? He said, well, the finishers didn't complain that the rocker sand wasn't sticky, it wasn't rocky, it wasn't, and the likelihood of your cement producer having problems is really low. So you're not checking all your water yet. And that was sort of a light bulb moment for me. So when we talked earlier in the earlier podcast about sand moistures and rock moistures,
Right.
that was the light bulb moment in my career when I understood it wasn't just the water that's going through the water valve or the Wade water system in the plant, and it wasn't just the water that was added at the wash rack or the job site, that sand moisture and rock moisture could be a major issue. And all we were doing at the time was checking that first thing in the morning before we loaded the first load. So we were getting 5 places out of the pile. We were doing the things we're supposed to be doing. We were only doing it once a day.
Right.
Well, those pours were happening, placements were happening later in the day that we were on that particular job. And the sand moistures had changed completely by that point in the day. So our concrete had too much water in it, and we were able to fix that moving forward. And luckily, none of the strengths were low to the point that they were actually low. They were
just lower than you expected.
Yeah, lower than expected. So they were still meeting design compressive strength, but they weren't performing where we wanted them to perform. So
you just kind of checked off cement and you checked off aggregates in a way, but
yeah.
There's one, and if you don't think about the story, I'm just going to kind of look at you really funny because it's the one that I created a huge spreadsheet for.
Yes.
But we talk about your concrete mix. I mean, from your batching process, the handling process, and even placement, and we kind of iterated it with workability that you adding more water during the placement of it is going to create that, or handling of cylinders and your test specimens. Yep. There's things you can do.
Yeah, the ASTM documents regarding testing are not suggestions. They are, the 60 to 80 degree initial storage temp, kind of for one thickness of concrete, those kind of things. That's very important to make sure that you're getting what you think you're supposed to get. But you brought up a very, very important point. And
there's actually 2 batching stories that I want to get into with you. Yeah. One is the big spreadsheet. One was the air that shouldn't have been there.
Yeah. All right. Good.
Because that was going to give us some issues.
All right. So story time, children. Sorry, I've just channeled Chef from South Park.
Once upon a time, many, many moons ago,
yes,
there was a young and resilient, wide-eyed
concrete QC guy
who had the world at his fingertips.
Yeah, but for whatever reason, I started having a rash of low breaks throughout the Chattanooga, Tennessee area, and could not for the life of me figure it out, because all of the things that I talked about before, checking, batch weights, checking, make sure all the right materials and the right amounts were going in, checking, make sure the moistures were good, all of those things, I was ticking all those boxes. And I could not figure out what was going on. So I went to Josh, who was with the testing lab at the time, and asked for some help because I couldn't put my finger on it. And Josh began tracking brakes. And he began tracking, and when we say brakes, I know that may be a term that's not broadly used either, but that's a compressive strength test result. We just say brakes because it's a whole lot easier than saying compressive strength test result. So Josh began tracking them, and he began tracking all the information associated with that load of concrete, including which plant it came from, which driver was carrying the load, what truck number it was, et cetera, et cetera. He had it all on this spreadsheet, and this is the largest, most cumbersome spreadsheet I've ever seen in my entire life.
One I never want to create again.
Yeah, it was like 20,000 data points or something like that. I mean, it was insane. So Josh called me a few weeks later. I don't remember the time, but he called me. He said, "Hey, I got to show you something." I'm like, "Well, what?" And he said, "Just come by the office." So I did. And then he shows me this spreadsheet, and by tracking all of that, he was able to identify a single driver that was the culprit of most of the loads that had low brakes. And I said it that way on purpose, a single driver, because that driver was a newer guy who was hopping trucks. He was going from truck to truck. I was expecting Josh to have found a particular truck that maybe had a bunch of buildup in it and it wasn't mixing well.
Which
That
would have
was
been
not
easy
the
done.
case.
You track into a truck number and go, hey, all these are low breaks come from one truck number.
One truck number, yeah. But that wasn't the case. If he had not taken the time to track the driver, we would have never found it. So I followed the driver to the job site. On a successive. Now, not all of the driver's loads were coming up low brakes, but there was enough to be concerned. So I followed him to the job site, and I noticed that this guy is running on mixing speed the entire way to the job.
Now, before we go any further, mixing speed versus transportation speed. And this is the drum spinning.
Yeah, drum spinning. So you got agitation speed, and I can't quote it anymore, but I think it's something where like agitation speed, normal drum turning on the way to the job is like 2 to 4 RPM. I mean, you're turning
There's an
that drum
ASTM
slow.
for it.
There is ASTM
C94.
C94. Mixing speeds much higher, much higher than that. And he was, we also call it full charge mixing speed. So he's riding the job with his drum just zooming, you know, in the middle of summertime.
Do that again.
All right. When I noticed, I followed him on two different trips, and when I noticed it, I called him off to the side. When he got back to the plant, I said, "Hey, need you to do me a big favor. Need you to slow that drum down to agitation speed." And he's like, "Well, what's that?" And I walked him through it, showed him the position on the lever. But that was back in the day when it wasn't digitally controlled. It was all
Teamwork it makes the dream work.
Yeah, exactly. And we were able to correct the situation, and that problem went away. So thank you again, Josh, for that. The diligence in tracking even the driver helped us find that low brake. The other story that you mentioned, we had do you remember if it was a power plant or was it a water treatment plant? I don't.
Water treatment plant, if I'm not mistaken.
Another water treatment plant. All right, so
we've only done a few of those.
Yeah. We were having some issues with a high air content. Now, correct me if I'm wrong on any of these details, because I don't. It was supposed to be a non-air mix.
Well, we were getting higher air than we anticipated, which was dropping strength. And what caught my attention was, so you will find back in the early days, and it's getting better, but you might still find some that while test agency are supposed to test air for every load of concrete, they don't if it's a non-air and trade mix. So
right.
Slab mix, a foundation mix, things like that nature. When it's out exterior, they're going to test it because there's a requirement. But interior slabs, it's not supposed to be in there, so they don't test it.
Yeah.
Our practice was to test air on every load that we tested. So slump air, temperatures, all that you're supposed to, because it's what we're supposed to be doing. And that's what caught my attention was a non-air and trade mix was having pretty decent amount of air, which is why I called you. Like, hey,
I remember it was like 5.5% on a non-air mix. Which is
and we'll get into
totally
it later. But most entrapped air is 1.5, no more than about 2%. And trained air gets up into the 4, 5, 6, 7. Hopefully nothing more than that. I don't think. But that's what caught my attention was we're getting in trained air in a non-entrained air mix.
Yep. So that just baffled me to no end because that shouldn't be happening. So went to I mean, I can't tell you. There was a couple of days of me scrambling around trying to figure out, okay, is something wrong with our admixtures? Was liquid air entrainment pumped into my water reducer? Tank, did a driver mess up? Do I have, so I'm checking everything. And then finally I'm like, okay, I got to just try to go to the source. I went to the plant and began trying to figure out what was going on, watched them load some loads going to that job, and I saw 0 ounces of air going into the truck. I'm like, okay, well, 0 ounces of air going into the truck, that doesn't make any sense. Truck pulled out, and I had the batch man just manually put out a couple 100 gallons of water. I said, just run some water out and let me look at your water. And the water came out, and as it came out, I don't know if you've had a kid like overfill a laundry washing machine with washing powders and seen like the bubbles that come out of a washing machine.
I've seen it on TV, but
that happened. Which got me, we've got literally knee-deep foam in the loading lane of the concrete batch plant. And,
Talk about a washout.
Yeah, so when I saw that, I knew we had a problem. At that particular plant, so I won't go into too much detail, but there's 2 ways to plumb in an air entrainment admixture line. 2 main ways, and one of them is a line full system, one of them is a line empty system. The line full system, you got a check valve. It plumbs into the water line. You got a check valve that keeps stuff from moving past. And you keep that line full so that when you call for it with the computer, it's right there, and it doesn't slow you down waiting on air to get all the way, the 40 or 50 feet from the admixture tank. That check valve had gone bad. And the water at that particular, this was a hoss of a concrete plant. It was a dry batch plant, but it would do 200 an hour. I mean, it was smoking. You had a 4-inch water main putting water into the truck with an air line that's plumbed into it. As that water is moving past that air line, it was creating a vacuum, which was sucking open the check valve,
so your air
which
entrainment
was
getting
pulling
pulled in.
air entrainment into the concrete. Yep. And that is one of those weird things that if that story can help any of you guys out there in the future who you're scratching your head trying to figure out where a low brake's coming from or high air's coming from, then it was worth telling that story. But yeah, it had me scratching my head, man.
Yeah. Moving beyond, then we start getting to temperatures. Temperatures
Yes.
of air, whether it's hot or cold, can affect it.
Yep.
Temperature, so what we're placing it on. Then you get into temperatures of the concrete. I mean, I think the worst conversation I ever had with a batch man was I was on a job site that actually had a temperature spec.
Yep.
And they had a QC guy watching everything I did. And he goes, I need to put that thermometer in there now. I was like, okay. And it was the truck. We just had to delay. And he's like, I want to test that truck right now. I was like, yes, sir. I stuck the thermometer in, and it was above it. We sent the truck back, and the batch pan just hit the roof. What do you mean you're sending me back for temperature? I'm like, I didn't. He did. And because at that time they're worried about that set.
Yeah.
And that it already started getting into that part, which can give you some strength issues. And there's other things you can do to manipulate that. I mean, from a testing company, we want to do everything we could. What we told our guys, and I'm going to say something. I know you can actually do things to manipulate that, but it was easier for us to tell you guys, look, from the time that concrete comes off that truck, nothing we do is going to make that concrete any stronger. Everything we do can do nothing but harm it, so do everything possible to do everything right. Yep. And it just kind of set the stage for, hey, mind everything. Yep. So from our initial curing and making sure that we're putting our cylinders where they did, I mean, I had a superintendent ask me one time to put my cylinders in his job trailer because it was going to get cold. And I'm like, sweet. Walked in there, stood there for a few minutes, and everybody that walked by, I felt the whole trailer shake. I'm like, not really where I want to put my cylinders.
Right,
and I explained to him why, because I didn't want that movement, because that would affect the strength of the cylinders, which means we're going to go out and core it. So the curing of the cylinders, the curing of the concrete, I mean, if you're not properly curing that concrete, you're going to do detriment to that in-place concrete.
Absolutely.
So that's why we mentioned hot weather, cold weather, and curing practices, to give that concrete everything we can do to achieve what it needs to. Yep. We talked early on about design strength. Yes. And for the most part, everything that you see come out is a PSI at a 28-day break. Yes. Because that is the living and breathing majority of everything you ever do. But there's also early strength and slower strength. Yep. And early strength, I did plenty of 3-day breaks, 1-day breaks, because they had to have, something at a certain point. I've had ramps that need to be loaded in 16 hours, so we're doing early breaks. Mm-hmm. I've had some that I made concrete and I picked them up 4 hours later because they had to have breaks, and I broke cylinders every 2 hours. Yep. Because they wanted to load it and they had to have a certain compressive strength. And so I was on job site at like 7 o'clock on, say it was a Wednesday morning, and I come pick them back up on my way back through, take them, break them at 4 o'clock, strength's not there. Break them at 6 o'clock, strength's not there. 8 o'clock at night, 10 o'clock at night. They was like, let's just push it beyond. 1 o'clock in the morning, I'm breaking cylinders. At 5 o'clock, I'm breaking cylinders. I call the superintendent, like, hey, you're going to have to call back at 8 when somebody else gets here. I've got to go to another job site.
Yeah.
because I had to be at a job site at 6 o'clock that next day.
Oh man.
So it was one of those where I worked around the clock. I did stuff in the lab just to keep myself awake and busy. But breaking solars every 2 hours.
Stuff not meaning drugs, right?
Why would you even bring that up?
Well, just 'cause
actual
it was
lab
funny.
work, like
Okay.
soil work, soil proctors, permeability, breaking other cylinders, stripping cylinders, weighing cylinders, processing cylinders, all kinds of things I was doing.
So I made that joke just because I've known Josh for 20 plus years, and I know he's never even tasted a drug that wasn't prescribed by a doctor. So
Yeah, and even then, I really don't like them.
Yep.
But we've also seen slower strength designs.
Yep.
Where due to mass placement
Yep.
or other things, we were pushing, the design strength out to 56 or 90, which from a batching process, from a design standpoint, we're adding a lot of SCMs, cementitious materials into it to slow that strength down. So
Yep.
you didn't get that heat. So we talked about heat of hydration in the first podcast.
Yep.
We wanted to drop that down. So the strength development was designed and meant to not do it at 28 days, but do it at 56, do it at 90 days. So there's other things you can do. So when you're talking about compressed strength, flexural strength, that's working with the design. Let's looking at with the design professional, looking at the design of what you need and looking at all the parameters. It's not just I want X. It's I want X at this time because these other components are coming in. With everything, with concrete as phenomenal as it is, there's a lot of things you can do and a lot of painstaking processes that need to go into place, and a lot of thought goes into it.
Yes.
It's not just order concrete, place concrete.
Right.
As many times as from a test man, I got told that the form fairy showed up in the middle of the night, and we forgot to call you. That's never been the case. You're planning way ahead for these things.
Yep.
And so as much as we plan from a design standpoint, from a build standpoint, from a pre-construction conversations with the finisher and knowing everything and getting into the tolerances of floor flatness, floor levelness that they need sometimes, the little things sometimes get overlooked.
Yes, they do.
Where's the test man going to set up? Where's the test man putting his cylinders? Because that matters as to what you see before you actually get into in-place strength.
Yeah, so this brings up a really good point. Several years ago, I put together a concrete placement. I call it a pre-pour checklist, and that's something that leave us a message if you'd like to see it, want to put it to use. I used various industry sources to put it together. Didn't copy anybody, just got ideas from others, put it, and based on my own experience, pulled it all together. And that's something that I've used for 15 to 20 years. And it has things like where are you going to set up for testing, where are you going to put your pump truck, where are you going to do this or that. It's just in the spirit of being helpful, and it's not anything prescriptive. It's not anything, no mandatory language or anything. It's just saying, hey, here's some things you might want to think about if you're going to pour concrete. And if you guys want a copy of that, just let me know. We'll send that out to you free of charge.
That's about all I got for strength of concrete. But, like, subscribe. If you got any questions, reach out to us. We'd love to talk to you more about it. And if there's anything that anybody thought we overlooked or missed or we got incorrect, please let us know. We'll be more than happy to give a shout out to you for, whatever it is, whether it's a question or comment.
Awesome. Thank you so much, Josh. Thank you guys for listening. We love you guys, and let us know how we can help.
Thanks.
Thanks for joining us for Two Wheelbarrows and a Place We Call Home with Josh Carroll and Brent Rollins.